Now we'll discuss the trajectory of a two-dimensional motion. As we have studied, two-dimensional motion is the motion of a particle in a plane. When a particle moves in a plane like this, say if we are having an xy coordinate system and a particle starts from point A and say it goes to a point B along this path, then this path of motion, whatever path particle follows, this path of motion we term as trajectory. So trajectory is the path which particle follows, or it is the locus of motion of the particle. Now as the particle moves in a coordinate system, this path must have an equation which relates y and x coordinate, or say if we relate a function in y and x coordinate according to which the particle is moving, this equation y equal to f of x we term as equation of trajectory. So if we just talk about equation of trajectory, it is just the equation of the function according to which the x and y coordinate of the particle are related. At a particular point, say particle is having its x coordinate x and its y coordinate y, and this is the relation by which these coordinates are related. This we term as equation of trajectory. In general two-dimensional motion, we are having a split in x and y directions independently as a function of time. Like say particle moves along a path, then say its x coordinate varies with time with a function f1t, and say its y coordinate varies with a time, say function f2t. So these are the two functions which are giving us the position coordinates of the particle in two-dimensional motion. In this situation, if we eliminate t, say if there's equation 1 and there's equation 2, eliminating t from 1 and 2, we get the relation y is equals to f of x. So you just need to express the position coordinates of particle as a function of time, and then by eliminating t, the time factor between the two equations, will get the value of the equation of trajectory, or will get the relation equation of trajectory in this situation. Let us take up an example on the trajectory of a two-dimensional motion. Here we are given that if a particle travels in a two-dimensional motion with velocity given as 4t I cap plus 5 j cap, and we are required to find the path of motion of particle and its equation of trajectory if it starts from origin. Here we can simply analyze that as velocity vector of the particle is given as 4t I cap plus 5 j cap. So here we can see this 4t would be the x component of the velocity of particle and phi is the y component of the velocity of particle. So here we can write velocity in x direction is 4t and velocity in y direction is 5. We can also put units, say these are meters per second. In y direction particle is moving with uniform velocity. So we can simply state the displacement of particle in time t can be directly written as 5t, because if it is moving at 5 meters per second in time t, how far it can move along y direction, that is y, that is 5t, as it is given that it starts from origin. Now in x direction, if we wish to calculate the displacement, we can write this vx as dx by dt, so it can be written as dx is 4t into dt. Now we integrate this expression. It is given that at t equal to 0, particle starts from origin, so the lower limit will be 0. At a general time t, say particle reaches a position x. So from here we can easily calculate the x displacement of the particle. That will be integration of 4 into t dt, that will be t square by 2. So it will be 2t square. Now say we take this as equation 1, this as equation 2. From here we can calculate the t, that is y by 5. And if we put the value of t over here, we'll be able to eliminate the factor of t and we get a relation in x and y. Now from equation 1 we can directly write x is equals to twice of y by 5 whole square. On solving this, we get x is equals to 2y square by 25, or we can write y is equals to 5 root of x by 2. So this is the answer to this question, and this we can write as equation of trajectory of particles motion, and as being a quadratic equation, its path will be a parabola, or you can say particle is moving in a parabolic path. So these are the answers to this question. Now we are going to study about the calculation of distance traveled by a particle in two-dimensional motion. We have studied that in two-dimensional motion, when a particle moves, its path we term as trajectory. So distance traveled can be directly written as length of trajectory or length of path. So if we talk about a general two-dimensional motion, so if a particle moves in a xy coordinate system from a point A to a point B, then in this trajectory, if we are required to calculate the distance traveled by the particle, it is certainly the length of this path, which is the distance traveled. If we are required to find the displacement of particle, it can be directly calculated by using the displacement vector of point B, that is the end point of the journey from with respect to the starting point of the journey. This is from A. Now, if we are required to find the distance traveled, we need to integrate the path length over this whole path. Say for example, at a particular point P, the particle was having coordinates x and y, and the particle is moving with a velocity vector v along the path. So in a time dt, it has covered a displacement dl along the length of the path. So we can simply state in time dt, its x coordinate is changed from x to x plus dx. It has progressed forward by a distance dx. Similarly, its y coordinate is also increased by a distance dy. So it becomes y to y plus dy. We are required to find the integration of this length dl over the whole path length from a starting to end point of the journey. So here we can simply state length of path L from A to B can be simply written as integration of dl. This can be written as integration of this dl can be written as vector sum of this dx and dy, which can be calculated by Pythagoras, that is root of dx square plus dy square. Further, we can take this dx common, so it becomes root of 1 plus dy by dx whole square into dx. We have just taken this dx common out. Now, again the total path length AB can be written as integration of this is root of 1 plus dy by dx whole square into dx. Now, as we are integrating the whole function or this integrand with the respect to the x coordinate, so we can simply integrate it from xa to xb. So it will be integrated from xa to xb. This will give us the total path length starting from point A to the point B. Be careful about this result. This result can be directly used for calculation of path length in any two-dimensional trajectory. This can also be written as, if we are given with the equation of trajectory y equals to f of x, you can easily calculate dy by dx, which will be f prime x, and it can be written as integration from xa to xb. Between any 2 points, you can find out the path by substituting proper limits. It is root of 1 plus f prime x whole square into dx. Very carefully, you just need to note down this result because in several cases it can be used.